This video is going to go through and hopefully give you a better idea of what a p-value is actually measuring. There's an old murder case that happened in Summerville, South Carolina in the mid-1980s. A woman was found murdered in her home, and after an investigation, the police arrest Tim for the crime. And let's say that you're on the jury. The evidence will be described one piece at a time. After each piece, you want to determine if you convict Tim of the crime. You want to remember, since you're on the jury, your null hypothesis is that Tim is innocent. That's your default belief. Without any evidence, you'd have to say that he's not guilty. And the alternative hypothesis, what you're trying to be convinced of, what the evidence is always going to argue, is that Tim is guilty of murder. So let's go through the evidence one piece at a time. The first piece of evidence is that he admits to speaking to the woman the day before at her house. If that's the only evidence that the police had on Tim, that's probably not enough to convict him of murder, because assuming that he's innocent, this wouldn't be that unusual to happen. There's probably plenty of people that spoke to the murder victim the day before she was murdered. This alone isn't strong enough evidence because it's not that unusual for someone to speak to her before she's murdered if they're innocent. Second piece of evidence was an eyewitness that places a man with the same height, hair color, driving the same car, in popular jacket, in the neighborhood around the time the crime took place. That's stronger evidence. That's a little more unusual for that to have happened, for him to be in the location if he was innocent. But it's still probably not unusual enough to go beyond a reasonable doubt that he's innocent. The p-value isn't quite small enough. A third piece of evidence was that a dry cleaner says that Tim came in with his jacket and asked for it to be cleaned, and it's the same jacket that an eyewitness saw a person wearing, which had several large bloodstains on it. Now, assuming he was innocent, is it unusual for all three of these to have happened? And yeah, it would be pretty unusual. None of this definitively tied Tim to the crime, but the jury found this convincing enough to convict him, because all three of these happening, assuming he's innocent, would be rare, and they figured that was beyond reasonable doubt and enough to say that he was guilty. So they changed their mind from innocent to guilty based off these three pieces of evidence. Eventually, Tim had his conviction appealed. He got a new trial, and after some time, they managed to do DNA evidence, and it came back that DNA evidence found underneath the woman's fingernails matched Tim's. So even at his retrial, he was still found guilty. Is it possible for all four of these things to have happened while Tim is innocent, that he didn't murder her? And it's possible that you could construct a scenario where all four pieces of evidence happen while he's innocent. It's just, for our second example, let's say that we're having an in-class exam, and there are two different versions, exam A and B, and question 18 has two different answers depending on the version. The answer for exam A is 328.4. The answer for exam B is 731.2. So two very different answers. Let's say that Jim has version A, and his answer for question 18 is going to be 731.2. Well, grading the exams, that would come back awfully suspicious. And I'm going to believe that Jim is cheating. So I want to lodge a complaint against Jim. When we're arguing if a student is innocent or guilty, the null hypothesis about any student is that they didn't cheat. And the alternative hypothesis, the one that we have to prove, or at least I have to prove, is that Jim did cheat. So those are our two hypotheses. Jim didn't cheat, Jim did cheat. And this is the one that I have to prove. So I'm going to present my evidence. Question 18. Jim should have put 328.4, but he put 731.2. His answer was that he just randomly picked a 4-digit number, and that's the one that he put, 731.2, and it just happened to match the other version. What we can do is let's find the probability that if Jim's just blindly guessing, he happened to pick the answer to the other exam exactly. So our p-value, assuming that Jim didn't cheat, I want to find the probability he would get this as his answer. Well, there's 1 in 10 chance he puts 7, 1 in 10 chance that he puts 3, 1 in 10 chance that he puts 1, 1 in 10 chance that he puts 0.2. If you work all that out, that's 1 in a 10,000 chance that Jim just happened to put the right answer to the wrong version, just by dumb luck. What I would have to believe, if I'm sticking with my default assumption that he didn't cheat, is that Jim just happened in this case to get really, really unlucky, putting the right answer for the wrong exam. So we have a really small p-value, and hopefully what's the conclusion somebody would reach is that Jim cheated, because the probability of him putting the right answer to the wrong version, assuming he didn't cheat, is really small. The probability of him putting the right answer to the wrong version if he did cheat is a lot higher than 1 in 10,000. So the evidence strongly suggests that the alternative hypothesis is the more likely explanation for the evidence that we have. Alternatively, let's say Jim put answer B for question 23 when he should have put answer E. So that's our p-value for question 18. For question 23, the p-value would be the chance that he just happened to put B at random instead of answer E. Well, if the choices are A, B, C, D, and E, that'd be 1 in 5, which would be a p-value of 0.2. Well, that's not that unusual, right? There are plenty of questions on the exam. If you're just going through blindly guessing, several multiple choice questions are likely to be the right answer for the other version. Doesn't necessarily mean that Jim cheated. Because the p-value here isn't small, there's not enough evidence to say that he cheated, because this wouldn't be unusual to happen if Jim didn't cheat and he just picked the wrong letter to match the other one. So for this situation, for question 18, if he gets the right answer to the different version, very compelling evidence. Whereas for question 23, if he puts the right answer for the wrong version, not that compelling evidence, because the two probabilities are very, very different. And again, these aren't the probabilities that the null or the alternative hypothesis is correct. These are the probabilities of Jim's answers occurring, assuming Jim didn't cheat. Let's say I decide I want to play a round of blackjack, but there aren't any casinos around anymore now that there's a lockdown. So I do the next best thing. I find some back alley casino in the back of somebody's old business, and I sit down. And they present the deck, and if they show the deck and don't reveal anything, my default assumption is that'd be a regular set of playing cards, where half of the cards are red and half of the cards are black. So the dealer shuffles up, starts dealing out the first set of cards. And he deals out 10 cards. Would this be suspicious? You don't know anybody, you haven't seen the deck. These are the only 10 cards that you observe. Well, it should be somewhat suspicious. It would kind of throw off your default assumption, because the chances of getting these 10 cards, if the deck itself was fair, would be really, really small. This would happen, all 10 cards being red, about 1 in a million chances. So we have an unusual sample of the deck if we believe the deck is fair. And this kind of comes back to the idea that the p-value is about what you observe. The p-value are about these 10 cards. We make an assumption about the deck. The deck is our population. I'm assuming that the population proportion is 0.5. If that was the case, this would be a really unusual sample to get. Our p-value would be 1 in a million, indicating our sample is very rare. Therefore, I have strong reasons to reject my null hypothesis. Again, this deck is either fair or isn't. There is no probability behind it. The p-value is about the 10 cards that we see, not about the population itself.